Now that we have talked about self-organization and a little bit about synchronization, let's discuss synchronization in a more detailed way. So it's basically represent or arrange events which follows the local rules by components or the actors. That indicates coincidence of simultaneous behavior or basically coexistence. That's the definition of synchronization. In other words, in a simple word, synchronization is something. That something can be an activity, a behavior, a property that simultaneously happening among all components. And obviously, since they don't have the global knowledge or the blueprint, they're going to act based on their local information. So there should be some form of self-organization behind synchronization. Again, the same way that self-organization and emergence are multi-level, meaning that self-organization emerges, and as a result of that self-organization, a different behavior emerges. So emergence comes before self-organization comes before emergence. The same story is true here. Because of the coupling and synchronization, we have a self-organization, and because of self-organization, we have synchronization. So this can happen in multiple levels, and in nature and physical environment, as well as built design environment, engineered environment, as well as abstract systems, we see synchronization that is very common. For example, your brain neurons, or generally nervous system neurons, fire synchronously, and that has an implication for also in heart cells beating synchronously. That is critical for our life, as well as many other, like crickets chirp synchronously, fireflies also flash synchronously. So these are all examples of synchronous behavior that is very common in complex systems and is one of the characteristics of these systems. In order to have a better understanding of this, let me show you a very common example that is, you might be familiar with it, and that's this example of a spontaneous synchronization that has happened because of the fluctuation that each of these tools, music tools, is creating. So at first you can see that they are not synchronous, whether the way they are pointing, the lever is pointing, or even from the sound. That when I play this video again, I'm going to stop talking so you can listen to the song and see, listen to the ticks, and see that the ticks are not really synchronous. But over time, since this surface is basically located on two soda cans, that gives the ability to the surface to basically, for these separate devices, to communicate through their basically fluctuations through this surface. And as a result, over time, we are going to see this synchronization emerges from this entire system. And the reason that you feel that some of them are synchronous and then like it's becoming synchronous but suddenly it become asynchronous is that because they are coupling again. The one is coupled to one its right, the one is coupled to one its left, and then because of the one that has produces stronger wave or shake on the left, the behavior on the right changes. So they are coupling with each other in various distances, and therefore you see some form of randomness, that they are becoming synchronous, then suddenly become asynchronous, and again more synchronous, asynchronous, synchronous, and finally it's going to reach the synchronous state. And there you go. That's pretty much synchronous. They're pointing at the same direction. Their wavelength is the same. And the ticking is almost completely synced. And this is how synchronization works. Let's now check our simulation for the synchronization. We are going to use the example of Fireflies. So in this case, to start with, I'm going to show you only one. In order to be able to set this value to 1, I'm going to click on Edit and then set it to 1, and then we have so these are the rules. How many flashes this Firefly should see in order to start syncing with that flash. That's the first rule. That's the first parameter. The other one is how long the flash should last. The other one is the cycle length, and this is actually a very important one in this example. Fireflies have their own inner clock or inner cycle that basically oscillate between flashes. So this is like their neurons basically pile up the excitement to a level that they release that flash. And let's say, for example, in this case, it's set to 10. So it's going to take 10 ticks until next flash. Now, whenever they see in their immediate surrounding, they see another fire flashes flashing. Now, depending on how many flash they should see in order to start syncing, they have two strategies to sync with that. One is delay. So basically, they are going to try to reset their cycle, inner cycle, or oscillator, basically, to flash with the other one. Another strategy is to advance, and the advance is completely opposite of the previous one. So they fast forward their flashing behavior so that they can match to the other Firefly. And again, when it comes to the why questions, we have many hypotheses, most of which are related to mating and reproduction. But when it comes, what we are really interested in is the how question and how this complex system again works. We are going to set the show dark flies to on so we can see all of them. In this case, I'm going to start with the one Firefly just to show you how it works. So this is the Firefly, and at this moment it's in the flashing state. It's randomly flashing and randomly moving around. So when I start by clicking the go button, you are going to see this is going to every 10 tick, which is the cycle length, this is going to flash for the duration of 1 tick. And all right, so we have already 70 ticks passed. So let me make this slower so that we can better understand the system. So this time it at 4, at 16, almost 15, at 39, and it goes like that. As you can see, it's very ordered, and every 10 tick it is flashing. That's how. And since we only have one, obviously this is going to go up to the top because the entire Firefly is flashing. So that's how this works. Now let's set this to a relatively large number, maybe something around 700. Close enough, 710. As you can see, this is the setup. They are facing different direction randomly, and randomly some of those are already flashing, and we are going to use the delay strategy, meaning that every Firefly that sees another Firefly, at least one Firefly around them that is flashing, it's going to try to delay so that they can flash synchronously with that one. And I'm going to start this again slowly, and then we can increase the speed. So this is how it goes. So far 13, 15 ticks has passed. So this is too slow. Let me speed this up a little bit. And as you can see here, the number is going up. So more fireflies are flashing. At this moment, we have like close to 80 something flashing. But as you can see, it's growing. So the ups and down that you see in this figure is the randomness. But overall, compared to the beginning of the time, right now we have more fireflies. Like right now we have 80 something. So I'm going to speed this process a little bit just to see how this works. And as you can see now, the flashing is becoming more and more. Now at the peak we have about 100 fireflies that are flashing. Again, it goes ups and down, and it is not very obvious when you look at this that they are synchronizing. And consider that the random movement has very important impact, because when they go away from the ones that are flashing and don't see any other one flashing, they start again randomly flashing. But gradually they are becoming synchronous. So I'm going to speed this process up. And here you can see now we have the maximum of 120 something that is flashing together, and this process continue increasing. So let's speed this further up. And as you can see, again, now we have about 700 that are flashing simultaneously. We have a total of 710. So the moment we get to, 200 something is flashing. The moment we get to the top, it's going to be all 700 flashing. But you can already start seeing the synchrony among those that are flashing. So the pattern is kind of obvious. Again, these ups and downs are random. As I said, if this is a firefly flashing but moves away from the other ones and get to the place that no other ones is flashing, it's going to start randomly flashing. Therefore, these ups and downs are happening. But we are almost there. 670 of those are flashing at the same time. And we are now almost completely synchronized. And as you can see, all 710 fireflies are flashing at the same time. And this is the synchronous behavior that we were talking about that is emerging because of those simple rules that each firefly is trying in the coupling behavior that we talked about it before when we were talking about self-organization.